want to transform the red and green channels into something that will resemble the SD map like this. How do we do that? We need to normalize these values here, okay, the red and the green. So with an expression, we will follow this formula. So red, which is a set of values, minus the minimum, which is -1, and that will be divided by the maximum, which will be 1, minus the minimum, which will be -1. That's what we did. So from 0 to 1 on the red. The other ones will still become what they were, but we're gonna say exactly the same thing on the green. So we'll have the normalization on red and green. So now that we have that, that means that anything that we map, taking this as our SD map, will be mapped within the sphere from top to bottom. It's not going to be around the sphere, it's going to be on the face of the sphere that we see. If I now put this image here with the UV channels set to RGB, that's it. So now I have the entire thing from this point towards this one, bottom to the top, mapped to that same sphere. So that's what we did, and we can use this to fake reflections. One thing to retain with this technique is, no matter how weird your geo is, no matter how intricate the geo is, this will always work. So if I now have a geo that is something like this, it will still work. It will still map things correctly. So you can fake this as definitely fake reflections, no matter how intricate and difficult and weird your geo is. Okay, in this case I have this weird thing, and we are converting still things with the same type of expression from normals to SD map. One thing also that I want to point out is, this seems a bit too complicated, this expression here, but because there's so much polarity in these formulas, maybe we can simplify this a bit. So we're gonna say red minus -1, it's the same thing as putting +1. Minus and minus will turn plus, right? And then the division will be 1 minus -1, it's gonna be 1 plus 1. Again, minus minus turns plus, so 1 plus 1 is gonna be 2. So this can be simplified like this, and then you're going to do the same on the other one, like that. So this is a more simplified way of achieving the same thing. As long as you understand, you use one or another. One thing also related with normals, it's another property called refraction. But instead of using the normals as a base, so we can convert into something else, the refractions, the fake refractions, again, it's important to underline that this is fake refractions. It's something that we can use a bit more directly. So we're going to use the normals like this, and we're going to copy just 2 channels. We use an ID store, so we're going to just copy red and green. We're going to put this on any channel. Let's call forward, and now the ID store will take those channels, those vectors forward. That's the one that we've assigned, and now you're going to start scaling this like that, and you'll see that the more you go up, you're going to see that this will look like fake refraction. Okay, you're distorting those channels like that. You can change the channels if you want. You can say instead of red and green, you can put blue. We'll see what this gives us. It will give you something different. Because red and green is going to give you the horizontal and vertical directions. Maybe that will be enough, but you can choose whatever channels you want. Let's not forget that what you have to do now is to use the alpha channel, so you cut just the part that you are interested in, so you don't have problems with distorting the actual background or the map itself. So you'll have just this, and then you put this on the background. And you can take a step forward, which is you can, again, you tick this one off, but you can force the normals to take any other values like this. So if you play with these things up and down, you're going to force the values to become something else, which can be even stronger, and you can achieve different things, different looks. For example, if you go up with the black point, you'll see that now the mapping is slightly different. In the same way you do this with this guy, it will be something different as well. It will give you more a different kind of refraction value. The method again will work no matter how intricate your geo is. It will always work in this way, and it will always, if you want to go up and down with this, you will see that the distortion will behave as expected in terms of the background you have. So you can go up and down. You'll see that the refraction will be something that will take the background, the new background, in consideration. So you're not going to have always the same. And you can rotate this around as well, and you'll see that this will also give you the same kind of behavior. This is a great way of achieving fake refraction, and I've used this many times actually. All you need for all of these techniques is just normals, and maybe this will serve as a base for you to achieve other things that you might think of. it's important to understand the concept of normals. The same goes for any other type of vectorial space, because this will open up your mind greatly to achieve many different things that otherwise you wouldn't be able to, because you don't understand the concepts, even though you use those spaces or those vectorial spaces to do the normal work that you do. But as you can see, if you take a step forward, things will be opening up for you to achieve much better and greater things.